Metal halide lamps can be affected by cold weather, especially extreme cold temperatures below 0 degrees Fahrenheit. The mercury inside the lamp can become too viscous and unable to ignite properly, resulting in lamp failure. Another possible cause is ballast failure. A defective ballast can prevent the lamps from igniting, even if they are still intact. The buzzing sound coming from the pull base indicates the ballasts are attempting to start the lamps but failing. Another possibility is a wiring issue. Loose or damaged wiring connections can interrupt the power supply to the fixtures. Also consider lamp socket issues. Corroded or damaged lamp sockets can prevent proper electrical contact between the lamps and the ballasts. When troubleshooting, firstly inspect the lamps visually to check for any physical damage or signs of burnout. Secondly, use a ballast tester to verify the functionality of the ballasts. If a ballast fails the test, replace it. Thirdly, thoroughly check all wiring connections to ensure they are secure and undamaged. Fourthly, clean lamp sockets using an electrical contact cleaner to remove any corrosion or debris. Other considerations include recent maintenance. Inquire about any recent maintenance or repairs performed on the lighting system that may have affected its performance. Since the fixtures are likely under warranty, it is best to contact the installing contractor for prompt repair or replacement. It is recommended to use metal halide lamps rated for cold weather operation -40 degrees Fahrenheit or lower in extreme cold environments. Consider installing ballast protectors to prevent damage from voltage spikes or surges. Regularly inspect and maintain the lighting system to prevent future issues. Understanding the effect of temperature on metal halide lamps is crucial. Low temperatures can significantly reduce the vapor pressure of mercury within the lamp, hindering the arc discharge necessary for ignition. This is more pronounced in older lamps where the fuel gas composition may have degraded over time. Ballasts are the heart of metal halide lighting systems. They provide the necessary starting voltage and regulate the current during operation. Ballast failure can stem from several factors, including overheating, voltage surges, or component degradation. Testing the ballast involves checking its output voltage and current against the manufacturer's specifications. If the ballast is producing erratic or no output, it likely needs replacement. Wiring problems are common culprits in lighting malfunctions. Over time, connections can loosen due to vibration, corrosion, or thermal cycling. Visual inspection is key. Look for frayed wires, corroded terminals, and loose connections. Use a multimeter to check for continuity and voltage at various points in the circuit. Lamp sockets are often overlooked but play a vital role in ensuring proper electrical contact. Corrosion, dirt, and debris can accumulate in the socket, impeding current flow. Cleaning the sockets with an electrical contact cleaner can often restore proper functionality. Ensure the power is disconnected before cleaning to prevent electrical shock. In addition to addressing immediate issues, preventative maintenance is essential for long-term reliability. Regular inspections can identify potential problems before they lead to complete system failure. Check for loose connections, damaged wiring, and signs of corrosion. Consider implementing a schedule for lamp replacement to avoid widespread outages. When selecting replacement lamps, opt for those specifically designed for cold weather operation. These lamps typically contain a modified fuel gas composition that enhances ignition at low temperatures. Furthermore, ensure the ballast is compatible with the chosen lamp type. Mismatched lamp and ballast combinations can lead to reduced lamp life, poor performance, or even ballast failure. Ballast protectors offer an added layer of protection against voltage surges and spikes. These devices shunt excess voltage to ground, preventing damage to the ballast and other sensitive components. Consider installing ballast protectors on all metal halide lighting circuits, especially in areas prone to electrical storms or voltage fluctuations. Proper grounding is crucial for safety and performance. Ensure all lighting fixtures are properly grounded to prevent electrical shock and minimize electromagnetic interference. Check the grounding connections regularly to ensure they are secure and free from corrosion. The National Electrical Code, or NEC, provides comprehensive guidelines for the installation and maintenance of electrical systems, including metal halide lighting. Familiarize yourself with the relevant sections of the NEC to ensure compliance and safety. For example, NEC Section 410.30 addresses the support of luminaires, while NEC Section 600.6 addresses the wiring of electric signs and outline lighting, which can provide useful information if the parking lot lighting is similar in nature. When troubleshooting, it is essential to follow a systematic approach. Start by gathering information about the problem, such as when it started, what the symptoms are, and any recent maintenance performed. Then, use a process of elimination to identify the root cause. Always disconnect the power before working on any electrical equipment and use appropriate personal protective equipment, such as gloves and eye protection. Metal halide lighting systems are complex and require specialized knowledge to install and maintain properly. If you are not comfortable working with electrical equipment, it is best to consult with a qualified electrician. They have the training and experience to diagnose and repair problems safely and effectively. Consider the specific application when selecting metal halide lamps. For parking lot lighting, choose lamps with a high lumen output and a wide beam spread to provide adequate illumination. Also, consider the color temperature of the lamp. Warmer color temperatures create a more inviting atmosphere, while cooler color temperatures provide better visibility. Light loss factors play a significant role in the overall performance of a lighting system. These factors account for the reduction in light output due to dirt accumulation, lamp depreciation, and other factors. When designing a lighting system, it is essential to consider light loss factors to ensure the system provides adequate illumination over its lifespan. Regular cleaning of the lighting fixtures can help minimize light loss due to dirt accumulation. Use a mild detergent and water to clean the lenses and reflectors. Avoid using abrasive cleaners, as they can damage the surfaces. Lamp depreciation refers to the gradual reduction in light output over the lamp's lifespan. Metal halide lamps typically depreciate by about 20% over their rated life. When planning for lamp replacements, factor in this depreciation to maintain adequate illumination levels. Voltage fluctuations can significantly impact the performance and lifespan of metal halide lamps. High voltage can cause premature lamp failure, while low voltage can reduce light output and cause the lamp to flicker. Consider installing a voltage regulator to stabilize the voltage supply to the lighting system. Surge protection is essential to protect metal halide lighting systems from transient voltage surges caused by lightning strikes or other electrical disturbances. Surge protective devices or SPD divert excess voltage to ground, preventing damage to the lamps, ballasts, and other components. Consider the environmental conditions when selecting metal halide lighting fixtures. In harsh environments such as coastal areas or industrial facilities, choose fixtures that are specifically designed to withstand corrosion, vibration, and other environmental factors. Metal halide lighting systems are widely used in parking lots due to their high efficiency and long lifespan. However, they also have some drawbacks, such as their long warm-up time and their potential for color shifting over time. Consider these factors when evaluating metal halide lighting for a particular application. LED lighting is an increasingly popular alternative to metal halide lighting. LED lamps are more energy efficient, have a longer lifespan, and do not contain mercury. They also offer better color rendering and instant-on capabilities. Consider the life cycle cost when comparing metal halide and LED lighting systems. While LED lamps may have a higher initial cost, their lower energy consumption and longer lifespan can result in significant savings over time. Perform a thorough cost-benefit analysis to determine which lighting system is the best fit for a particular application. Smart lighting controls can further enhance the energy efficiency and performance of metal halide lighting systems. These controls can automatically adjust the light levels based on occupancy, time of day, or ambient light levels. Consider implementing smart lighting controls to optimize energy savings and improve the overall lighting quality. Occupancy sensors can detect when a space is occupied and automatically turn on or off the lights. This can significantly reduce energy consumption in areas that are not constantly occupied. Daylight harvesting systems use sensors to detect the amount of natural light available and automatically dim or turn off the electric lights accordingly. This can further reduce energy consumption and improve the overall lighting quality. Time clocks can be used to schedule the lights to turn on and off at specific times of day. This can be useful for controlling the lighting in parking lots or other areas where the lighting needs to be on only during certain hours. Networked lighting control systems allow you to remotely monitor and control the lighting system from a central location. This can provide valuable insights into energy consumption and allow you to make adjustments to optimize performance. When troubleshooting lighting problems, it is helpful to have a basic understanding of electrical circuits. A simple circuit consists of a power source, a conductor, and a load. The power source provides the electrical energy, the conductor carries the energy to the load, and the load consumes the energy. In a metal halide lighting system, the power source is typically the electrical grid, the conductors are the wires, and the load is the lamp and ballast. If any of these components fail, the circuit will not function properly. A multimeter is an essential tool for troubleshooting electrical circuits. It can be used to measure voltage, current, and resistance. These measurements can help you identify the location of a fault in the circuit. Voltage is the electrical potential difference between 2 points in the circuit. It is measured in volts. Current is the flow of electrical charge through a circuit. It is measured in amps. Resistance is the opposition to the flow of electrical charge in a circuit. It is measured in ohms. Understanding these basic electrical concepts can help you troubleshoot lighting problems more effectively. Safety is paramount when working with electrical equipment. Always disconnect the power before working on any electrical circuits. Use appropriate personal protective equipment, such as gloves and eye protection. If you are not comfortable working with electrical equipment, it is best to consult with a qualified electrician. Always verify that the replacement parts are compatible with the existing equipment. Using incompatible parts can damage the equipment and create a safety hazard. Follow the manufacturer's instructions when installing or replacing any lighting components. Improper installation can void the warranty and create a safety hazard. Keep accurate records of all maintenance and repairs performed on the lighting system. This will help you track the performance of the system and identify any recurring problems. Regularly inspect the lighting system for any signs of damage or wear. This will help you identify potential problems before they lead to complete system failure. By following these tips, you can ensure the reliable and efficient operation of your metal halide lighting system. Remember to prioritize safety and consult with a qualified electrician if you are not comfortable working with the electrical equipment. Consider the impact of lighting on the environment. Choose energy-efficient lighting systems and implement smart lighting controls to minimize energy consumption and reduce your carbon footprint. Dispose of used lamps and ballasts properly. Metal halide lamps contain mercury, which is a hazardous material. Contact your local recycling center for information on proper disposal methods. By taking these steps, you can help protect the environment and ensure a sustainable future. Metal halide lamps, while efficient, require careful consideration of their operating environment. The sensitivity to cold temperatures, as highlighted earlier, is a key factor. When temperatures drop below the manufacturer's specified minimum, the arc discharge becomes unstable, leading to reduced light output, flickering, and eventual lamp failure. The ballast, responsible for initiating and regulating the current flow to the lamp, is another critical component. Traditional magnetic ballasts are robust but can be susceptible to voltage fluctuations and harmonic distortion. Electronic ballasts offer improved performance, including better energy efficiency, reduced flicker, and longer lamp life. However, they are more sensitive to voltage surges and require surge protection. Wiring connections, often an overlooked aspect, are vital for ensuring a reliable electrical path. Loose or corroded connections increase resistance, leading to voltage drops and heat buildup. This can not only affect the lamp's performance but also pose a fire hazard. Regular inspection and tightening of connections are essential. Lamp sockets, responsible for physically and electrically connecting the lamp to the circuit, are also prone to issues. Corrosion, dirt, and mechanical damage can impede current flow, causing the lamp to fail. Cleaning the sockets with a non-conductive contact cleaner and ensuring proper lamp seating are crucial for maintaining a reliable operation. Recent maintenance activities can inadvertently affect the lighting system's performance. Incorrect lamp replacement, improper wiring, or loose connections during maintenance can all contribute to problems. Thoroughly documenting all maintenance activities and verifying proper installation are essential. Warranty coverage provides protection against premature failures. Familiarize yourself with the terms and conditions of the warranty, including the coverage period, exclusions, and procedures for making a claim. Contacting the installing contractor for warranty repairs ensures that the work is performed by qualified personnel and that genuine replacement parts are used. The use of metal halide lamps rated for cold weather operation is a proactive measure for mitigating the effects of low temperatures. These lamps are designed with a modified fuel gas composition that facilitates ignition at lower temperatures. Consider replacing standard lamps with cold weather rated lamps in areas prone to extreme cold. Ballast protectors offer an additional layer of defense against voltage surges and spikes. These devices divert excess voltage to ground, protecting the ballast and lamp from damage. Installing ballast protectors is a cost-effective way to extend the life of the lighting system. Regular inspection and maintenance are the cornerstones of a reliable lighting system. Schedule periodic inspections to identify and address potential problems before they lead to complete system failure. This includes checking wiring connections, cleaning lamp sockets, and monitoring lamp performance. By implementing a proactive maintenance program, you can minimize downtime and extend the life of your lighting system. Consider the use of light meters to measure the illuminance levels in the parking lot. This data can be used to identify areas with inadequate lighting and to optimize the lighting design. Regular light meter readings can also help track the performance of the lighting system over time. Evaluate the use of timers and photocells to control the lighting in the parking lot. Timers can be used to turn the lights on and off at specific times of day, while photocells can automatically adjust the light levels based on the ambient light. These control strategies can help conserve energy and reduce operating costs. Consider upgrading to LED lighting. LED offers significant advantages over metal halide lamps, including higher energy efficiency, longer lifespan, and better color rendering. While the initial cost of LED lighting may be higher, the long-term savings in energy and maintenance can offset the upfront investment. Evaluate the use of wireless lighting controls. Wireless controls offer flexibility and scalability for managing the lighting in the parking lot. These systems allow you to remotely monitor and control the lights, adjust light levels, and schedule lighting events. Prioritize safety when working with electrical equipment. Always disconnect the power before performing any maintenance or repairs. Use appropriate personal protective equipment, such as gloves and eye protection. If you are not comfortable working with electrical equipment, consult with a qualified electrician. Dispose of used lamps and ballasts properly. Metal halide lamps contain mercury, which is a hazardous material. Contact your local recycling center for information on proper disposal methods. Consider the environmental impact of your lighting choices. Choose energy-efficient lighting systems and implement smart lighting controls to minimize energy consumption and reduce your carbon footprint.